Alright, so here it tells us in the directions that we have these 3 points plotted on our graph. It's asking us to plot a 4th point in quadrant 4 that will make this shape a parallelogram. So what do we know about parallelograms? Opposite sides are congruent and opposite sides are parallel. So how can we use either of those to help us figure out where the 4th point should go? What do you think? Okay, so Wayne over here is saying it should be 5, -1. How did you get 5, -1? Okay, so you made it into a rectangle. So if you start here and you make this one went down 2, then over here we go down 2, and we can land in the 4th quadrant and have our parallelogram. So there you use distance and you use the fact that they both had to have vertical slopes to be able to help you with that. Okay, number 2, this time we're going to plot in quadrant 1. So quadrant 1 is up here. 4, 2. How'd you get 4, 2? Okay, well let's look at our slope. So here this had a vertical slope and it was up 2, has a length of 2. So over here I have to have a vertical slope and up 2, a distance of 2. So that ordered pair is actually 5, 3. So in using what we know about opposite sides having to have the same length as well as the same slope, you can find your points in the right quadrant. Okay, number 3 here. It's saying now it wants us to put it into quadrant 3. So quadrant 3 is down here. So again, you can use either segment and think about the slope of it or the length of it and try to match it. So do you want to use this one here or the second line here? Doesn't matter which one. The first one. So this one had a length of 1, 2, 3 with a 0 slope. Because the slope, we didn't rise anything, so we did 0 over 3, that's 0. So if I come down here, I have to go 1, 2, 3 with a 0 slope. And there would be my 4th point. And that's at -1, -1. Okay, so part of what we're going to be doing today is plotting 4th points, or making sure that we have the shape that we want. So this was just asking for a parallelogram. So we were able to use opposite sides congruent and opposite sides having the same slope to help us figure out that missing point. Okay, any questions so far on just how to find the missing point or tell if it's a parallelogram? Okay, if you flip it to the other side or to the back side, this is going to be more like what you're doing on your assignment today. So again, we have 3 points that are plotted for us, and we need to plot the 4th point in a quadrant. So this first one says quadrant 2. So quadrant 2 is up here in the top left. So if I need to plot a point over here, I'm going to connect the dots so that the space over in quadrant 2 is what's open. So then how can I find that 4th point? Anyone think they might have a guess for what the 4th point might be? Sarkis?
2 over to the left.
2 over to the left from which point?
The bottom.
From down here?
Yeah.
So just straight over here? That's going to make a parallelogram?
Or,
Charlie? Okay, it should be 2 to the left from the top point.
Yeah.
So if we go from the top point to the ordered pair negative 3, 3. We would have that same distance of 2, both with a horizontal slope of 0. Okay, so what you're going to be doing on your assignment is not only going to be finding the point, but then answering a question like the one below it to verify that you have a parallelogram using the slope formula. Yes, Krista?
How do you know to go to the top of the bottom?
So this was what I didn't know, right? So if I know these two, and I know that that has a distance of 2, I need it to be a parallelogram. If I were to go from the bottom and connect the dots, I'd actually have a triangle. So it's because I already counted 2 from the bottom here.
Yeah.
I needed to go to the top and count 2. Okay, so if we're going to verify it's the quadrilateral is a parallelogram using the slope formula. So first off, what is the slope formula? y2 minus y1 over x2 minus x1. So for this, I'm going to label my points just to make it a little bit easier for me to identify. I'm going to find the slope of AB and see if it equals the slope of DC. Because if the slopes are the same, that means our lines are parallel. So the slope of AB, A has the ordered pair negative 3, 3. B has the ordered pair of negative 1, 3. So y2 minus y1 over x2 minus x1. 3 minus 3 is 0. I have a double negative here. So that would give me negative 2. 0 over negative 2 is 0. So my top line has a slope of 0. So now I'm going to show the bottom line also has a slope of 0. So I'm going to now find the slope of DC. C has the ordered pair of 1, 1. D is negative 1, 1. y2 minus y1 over x2 minus x1. So I get 0 over negative 2, which is also 0. Because these are the same, we know our lines are parallel. So we've showed one pair of lines opposite of each other are parallel. That means we at least have a trapezoid. So to show parallelogram, we have to do the same thing for the other two sides. So now to show it's a parallelogram, we've got to do the other two sides. So we have to do AD. So we have y2 minus y1 over x2 minus x1. And I end up with 2 on top. On the bottom we have a double negative, so negative 3 plus 1 is negative 2, giving me a slope of negative 1. So BC should have the same slope if they are indeed parallel. So y2 minus y1, x2 minus x1, we get 2 over negative 2, which is negative 1. So because those are the same, we know the lines are parallel. So if it asks you to show something's a parallelogram using slope, you're just showing that opposite sides have the same slope. Okay, any questions on that? Just showing that opposite sides are parallel.
Sarah, what did you write under the 1?
Where?
No.
That,
Okay.
that's the symbol for parallel.
Okay.
So rather than write, I know it looks like an 11, I try to draw them really big, but it doesn't always look that way. Okay. Okay, so if we go to the second box here, this one it wants us to plot a point in quadrant 4. So quadrant 4 is down here. So since my point has to be down here, I'm going to connect the dots so that my open side is towards quadrant 4. So where does that fourth point need to go to make it a parallelogram? Charlie? 1, negative 1. So if we look over here, this went vertically down 2. So that means this side also has to go vertically down 2. So we can connect our points and have our parallelogram. Okay, now the question on this one says to verify the quadrilateral as a parallelogram using the distance formula. Because what do we know about the sides of a parallelogram? Opposite sides are equal. So how can we show they're equal? If the distances are the same. So if we go and we show, again, I'm just going to label A, B, C, D so that I can keep my information organized. A is at negative 1, 3. B is at 1, 1. C is at 1, negative 1. And D is at negative 1, 1. So if I want to show the distance between A and B is equal to the distance between D and C. So our distance formula, see, I don't really have a spot to write it here like I did on the other one. It's x1 minus x2 squared, and all of this is in a square root, plus y1 minus y2 squared. That's our distance formula. So that's what I'm going to be using here. So x1 minus x2 squared plus y1 minus y2 squared. Negative 1 minus 1 is negative 2. 3 minus 1 is 2. So 2 squared is 4. 2 squared is 4, so I end up with the square root of 8. So next I'm going to do the length or the distance of DC or CD. And our distance should be square root of 8 because they're supposed to match. So the top and bottom distances should match the sides, or should match and the sides should match. So for CD, x1 minus x2 squared plus y1 minus y2 squared. So we have a double negative in here, so 1 plus 1 is 2, so 2 squared plus negative 1 and negative 1 is negative 2 squared. 2 squared is 4, negative 2 squared is 4, so we end up with the square root of 8. Because those are the same, that means opposite sides are congruent. Now for AD and BC, because they're vertical, we can just count them to make sure they're the same. So we know that AD has a distance of 2. Because vertical distances we can just count. It's the slanted ones that we can't. So this has a distance of 2. BC has a distance of 2. Those are the same, so they're congruent as well. So this is how we can use distance formula to show opposite sides are congruent. Okay? You got it?
Yeah, just
Okay. All right, so first we had slope formula to show that opposite sides were parallel. Then we used distance formula to show opposite sides are congruent. Okay, the last box over here says we want to plot a point in quadrant 1 that will make this a quadrilateral. So quadrant 1 is up here. So I'm going to connect the dots and leaving the open spot near quadrant 1. Wait. So where should my fourth point go in quadrant 1? Charlie?
1, 3.
1, 3. Okay, so Connect the dots, you have your parallelogram. So this time it says to verify it's a parallelogram using the midpoint formula. So again, our midpoint formula is x1 plus x2 over 2, comma, y1 plus y2 over 2. So why would we use midpoint to verify? Well, do you guys remember what we know about the diagonals of a parallelogram? Not in a parallelogram, that's for a rectangle. In a parallelogram, the diagonals bisect each other. So if the midpoint of the diagonals is exactly the same, then you have a parallelogram. We know that the diagonals will bisect each other. So that's where midpoint can be used to help you figure out if you have a parallelogram or not. So what we're going to do for this one is check the midpoint of the diagonals. So again, if I label A, B, C, D, 1, 3 is A, negative 1, 3 is A, 1, 3 is B, C is 1, 1, and D is negative 1, 1. So if we go and find the midpoint of side BD, so that would be if I were to connect these two, what point is in the middle? I'm going to add the x's together, divide by 2, add the y's together, and divide by 2. That would give me 0 over 2 and 4 over 2, which will give you 0, 2. Which when we draw it, when we drew it in, it looks like it should be 0, 2, right? So where does it fall in the middle? At 0, 2. The other half you're going to check to see is the midpoint of AC also 0, 2. So if we do the midpoint of AC, again we'll add the x's, add the y's. So here we get 0 over 2 and 4 over 2. Our midpoint's at 0, 2. Because these matched, that means they bisect each other because they have the same midpoint. Okay, these are 3 different ways you can verify something is a parallelogram. By showing the diagonals bisect each other, by showing opposite sides are congruent, or by showing opposite slopes are the same.
Going back to the slope one, couldn't you just prove it by rise over run?
But yes, you could, and I'm going to go over that in a sec, but this said use the slope formula. That's why we use the formula. I'm going to talk about that when we get to your homework, because I'm going to have you guys use rise over run in your homework, otherwise your homework's going to take way too long. Or is that what you're on right now? Yeah. Okay, so number 5 here is more like what your assignment's going to be. You only have 9 questions on your assignment today, but each question can take some time. Okay, so that's what Tyler was asking about. I'll talk about here in just a second, because we'll do this one like I want you to do your homework. Okay. So on number 5 here, we have to plot the 4th point. And this time it says to plot it in quadrant 1. So quadrant 1, where would that point have to go to make a parallelogram? What'd you say? 4, 6. So if we use slope, so we know the slope between B and C is 2/3. So that means I go up 2 over 3. From A to D would have to have that same slope. So if I go up 2 over 3, I'll land on my D, which happens to be at 4, 6. So for part A, it says to use the slopes to show that you have 4 right angles. So how can slopes help us know if we have right angles? So think about, how does slope tell us 2 things are perpendicular? Because that means right angles. Okay, so does anyone remember how slope can tell us we have a right angle? When they're the same, we know they're parallel. but when they're this, we know they're perpendicular. Okay, opposite's part of it. Okay, so perpendicular. So you might want to write this. Ooh, that's, you can't see that. Okay, let's write this so that we all remember it. So perpendicular have opposite. So that means one's positive, one's negative, and reciprocal slopes. So if we look at AB, it told us it has a slope of -3/2. BC, it told us has a slope of 2/3. What does AD have? So AD has a slope of up to over 3. So that would be 2/3. And DC would have a slope of 1, 2, 3, down 3 over 2. So how we found the slopes of these by just doing the rise over run, that's how I want you to do slope on your homework. Otherwise, we're going to take way too long on our homework. So use the rise over run so that your homework doesn't take as long as opposed to the formula. So now, looking at these two, are they opposite of each other? So is one positive and one negative? Yeah. Are they reciprocals of each other? Meaning is one a flipped fraction of the other? Yes. If both of those are true, then you know that those two are perpendicular, meaning this is a right angle. Okay, what about AD and DC? So this angle and this angle. Are those opposite and reciprocal? Yes, so we know that's a right angle. Okay, let's see. What about AD and AB? So AB and AD, are these opposite and reciprocal of each other? Yes, so that means those two are perpendicular. And then you can also compare BC and DC. Those are also perpendicular. So by just comparing the slopes to show that they're perpendicular, you've shown you have 4 right angles, so you have a square, or at least a rectangle. Okay, so that's one thing you're going to do or use on your homework to help you show perpendicular or to show parallel. Those are the 2 ways slopes can help us, to show parallel or perpendicular. If you're trying to show that all 4 sides are congruent, that's distance formula. So you would have to do the distance formula for each side to show that they're all the same. Okay. So let's go ahead and practice the distance formula again, just because I know some of you guys are still struggling with distance formula. So if we were to find the distance between A and B, so A is at the ordered pair 1, 4. B is at the ordered pair of 3, 1. So we have the square root x1 minus x2 squared plus y1 minus y2 squared. So we have -2 plus 2 squared plus 3 squared, which will give us the square root of 4 plus 9, which is the square root of 13. Next, we can do BC. So C has the ordered pair of 6, 3. So 6 minus 3 squared plus 3 minus 1 squared. 3 squared plus 2 squared. So we get 9 plus 4, which is the square root of 13. So far, so good. We've shown 2 of the sides are the same, so we're on track for a square. Next, we would need to do CD. So we would have 6 minus 4 squared plus 3 minus 6 squared. So that's 2 squared plus negative 3 squared, which will give us 4 plus 9, which is the square root of 13. And then the last one we have to check is AD. Which would be 4 minus 1 squared plus 6 minus 4 squared. So 3 squared plus 2 squared. 9 plus 4 is also the square root of 13. So because all four of these were exactly the same, as well as all four angles were 90 degrees, we know for sure that this is a square. So if we were to go and do distance formulas and we got two sides were equal to each other and another two sides were equal to each other, what shape would that be? If these two were equal and these two were equal, in right angles, we'd have a rectangle. If these two and these two are equal, but we didn't have right angles, it would be just a parallelogram. Okay? So what you guys are doing on your homework, so go ahead and, it's the back 2 pages of your packet. So go ahead and turn to the last 2 pages of your packet. It should look something like this.